Okay, so here we have a question number 1 using a calculator. And this is kind of a typical calculator question where you are given a function that is a rate of change. Okay, so we are given the rate at which sewage enters, a treatment tank. So this is entering, okay? It's important to make note of that. So I always write up my free response. And it's gallons per hour, okay? Now I'm going to actually put this in my y sub 1. So in my calculator, this will be y sub 1, okay? Now we're told that it's between the hours of 0 and 4, so that's going to be the closed interval. And the treated sewage is removed from the tank at a constant rate of 645 gallons per hour. Okay, so then this is going to go in y sub 2, and this will be 645 gallons per hour. Okay, great. And that is the exiting. Okay, so this is leaving. So that would be negative, subtracting. Great. Now, the first question, how many gallons of sewage enter the tank between the intervals 0 to 4? So I'm given the rate of change. So to find the amount, I would take the integral of my rate of change, which is y sub 1 dt from 0 to 4. Now, it's really important that you show what you put in your calculator because you will get points for that. If you fail to show your work on calculator questions, you will lose easy points. So notice you get 1 point for showing the integral and then a second point for getting the correct value. So there'll be 3,981 gallons that will be entering, that will have entered between the hours of 0 and 4. Okay? Now, let's go to part B. For 0 to 4, at what time t is the amount of sewage in the treatment tank the greatest? So I want to find an absolute maximum. Now you know this is a key phrase. So basically I want to set the rate equal to 0, and that will give me my critical points, right? Now I also want to look at endpoints because those can be maximums, okay? So we're going to consider all of these values, critical points and endpoints. Then once I've found out which time the times that might be the greatest, I'm going to find out what is actually the maximum amount of sewage in the tank and justify your answers. Okay, so they want us to show work here, folks. Now I'm going to go to the next slide, my graph. So this is the graph of the function. So this is the graph of it entering, and then this is the graph of the rate at which the sewage exits. Okay, so if I want to find a critical point, then I need. Okay, so I have the graph here. Now, what I need to do is I'm wanting to find the critical point, or in other words, I want to find out when E prime, or actually it's just E of t because it's given to us as the rate, minus the removal is equal to 0. So notice I'm setting the rate of change equal to 0. Now, I'm also actually going to have E of t, I could think of it as this. When does E of t equal R of t? Because I've graphed both functions. So I can see that when time is 2.309 or when time is 3.559, those two functions will be equal. Now another way of doing this is you could have just graphed, E of t minus R of t, sorry, I'm hiding out in the copy room to make this video, equal to 0, and then calculated the zeros, and you would have gotten the same x values. So I have, as far as time and hours go, I have 4 critical points. Well, actually, I have 2 critical points and 2 endpoints. So my first endpoint is 0. My critical point is 2.309. And my next, there's the fire alarm. I've got to stop. Okay, I'm back after the fire drill now. So after 2.309, another critical point we see is 3.559. And then we also must consider the last endpoint, which is 4. So these are the possible values for a time when the treatment tank will be the greatest. So we are told at 0, though, that there is 0 amount of sewage. So we should label this amount of sewage. Now we're going to have to find the amounts for the other time frames, okay? So when we look at the integral from 0 to 2.309 of the amount entering, okay, and then we're going to subtract that from 645 multiplied by the time, which is 2.309. And that will tell us the amount of sewage, which is 16 37.18. Oh no, 0.178, sorry. Okay, now we repeat the same procedure for 3.559. So from 0 to 3.559, how much has entered? And then take away the amount that has been removed. And when we do the math, for this we get 1,228, and 0.520. So we can see that's less. Now the last value, actually we found this answer at the beginning, part A, when we went 0 to 4 of the value of the function e of t, and then we take away 645 times 4, and that is 1,401.022. So then our conclusion would be that the amount of sewage in the treatment tank is greatest at 2.309 hours. At that time, the amount of sewage rounded to the nearest gallon would be 1,200, oh, I'm sorry, I'm reading the wrong number, 1,637 gallons. Okay, now let's go on to part C. Part C now, they give us a function for the cost. Okay, now the key phrase I read in that, actually the key phrase that I read is that it says the raw sewage that enters the tank at time t is 0.15 minus 0.02 times t. So this is the cost, the cost of treating the raw sewage that enters the tank. So to the nearest dollar, we have to find the total cost of treating all the sewage that enters. So we are going to go from 0 to 4, and what we're going to look at is we're going to look at the cost multiplied by the amount of sewage that is entering. So that would be our e of t function. Now you can see when we look at unit analysis for this, it kind of makes sense because the cost is dollars per gallon, right? And then we're multiplying it by the rate, which is gallons per hour. And so our response then, our answer that we get, will be in dollars per hour. Okay, and then when we put that into our calculator, so the total cost of treating the sewage that enters a tank in the nearest dollars would be 474. So for this problem, you get a point for the correct integrands, the point for the correct integrand, a point for the correct limits, and a point for the correct answer. And that is question number 1 with calculator.